Assalamualaikum warahmatullahi wabarakatuh and a very good morning. In this video, we are going to learn the last topic for the hypothesis testing, which is the hypothesis test involving the ratio of two population variances. So this hypothesis test is to compare the variability when comparing two populations. So for the hypothesis test involving the ratio of two population variances, the hypothesis for this will be, the null hypothesis is given as the population variance from population 1 equals to the variance from the population 2. And the alternative hypothesis would be for the greater, it will be reject hash node if f test greater than f alpha n1 minus 1 n2 minus 1. So for this case of the ratio of two population, we will use f test. Okay, and then for the variance from population 1 less than variance from population 2, we will reject hash node if the f test is less than. So you can see the difference here is we use the f1 minus alpha, n1 minus 1, n2 minus 1. And the last one for the case of the alternative hypothesis that the variance are not equal, we will reject hash node if the f test greater than f alpha over 2, n1 minus 1, n2 minus 1, or if f test is less than f1 minus alpha over 2, n1 minus 1, n2 minus 1. Okay, here we also can find the value of f1 minus alpha, n1 minus 1, n2 minus 1, where this f is equivalent to 1 over f alpha, n2 minus 1, n1 minus 1. So you can see the degree of freedom is changing. Okay. So the test statistic for the ratio of two population variance is given as f test equals to s1 square over s2 square. Right, so how can we find the critical value from the f distribution? So given we have the value of alpha, so we can just find the value of alpha on the top of this column. Okay, so here is the table for alpha equals to 0.05. Next is we need to identify the value of n1 minus 1. So this is the degree of freedom for numerator. So here normally we define it as v1. Okay, so v1 is equals to n1 minus 1. Next, you should know the degree of freedom for the denominator. So the last value of degree of freedom here refers to the denominator. So let's say you want to find the f value given alpha is 0.05 and the numerator is 6 and the denominator is 4. So it will be, the value is 21.97. Now let's try this first example. So a machine cut 10 plastic rods before it was serviced. The observed weight for the 10 plastic rods had a variance of 3.6 grams. After the machine was serviced, 7 plastic rods were cut and the variance of weight was 2.5 grams squared. So did the machine improve its operation after being serviced, after being served? So test at 5% level of significance. So here we have two different conditions. The first one is where the plastic rod before, the condition of the plastic rods before it was serviced and also after the service. So the number of plastic rods that is observed before the service is 10, and the variance here refers to the sample variance. Okay, given this is the variance for the 10 plastic rod, so it will be s square from the before service, which is equals to 3.6. And then now is the case after the machine was serviced. So 7 rods are cut, so NA would be 7, and the variance of weight would be 2.5. So we want to know whether the machine improved its operation after being served, and given alpha is equals to 0.05. So the procedure to solve this is the same. The first step is that we have to identify the hypothesis for this. So the null hypothesis would be, so did the machine improve its operation after being serviced? So this one referred that the variance after service is better than before service. So the arrangement of this should also the same for the null hypothesis. So it will be after equals to the variance before, and then our alternative hypothesis would be the variance after better than the variance before. So now the next step is to identify the test. Okay, so the F test, since it is the two population variance, so it will be S square 1. So 1 refers to the before and 2 refers to after. So 3.6 over 2.5, which is equals to 1.44. So now we have to check, okay, the critical value. So this is, so since the null hypothesis is greater than, which means that if F test is greater than the critical value, which means that we have to reject H node. So first identify what is the F 0.05. So given N1 is 10 minus 1, and for the numerator it will be 7 minus 1, which is F 0.0596, where the value of this is equals to 4.1. So this is the value of the F value. So you can see the value of F test is 1.44, which falls less before the value of critical value. So since F test is equals to 1.44 less than F 0.0596, thus we accept H node, which means that the data does not provide enough evidence that the service had improved its operation after being served at 5% level of significance. So that's how you solve the hypothesis test involving the ratio of population variance. So that's the end of chapter 6.